So here in this case, this is basically we are in this theory we are deriving relation between wavelength and refractive index. All right.
Yeah.
So let's draw the diagram. So this is our surface. Here, let's say it's a glass medium or any denser medium. Okay, you can take it as water also. Let's take water.
Okay.
So it must have a refractive index, right? Let's call it mu. And the rays which are coming from is, let's say, having a refractive index mu1, or it's an air. So in this case, in that case, air is having refractive index as 1, right? So let's say
Yeah.
a plane wavefront hits this surface. Now it's a plane wavefront. Okay, right now we are treating this thing, this light, as a wave. Okay, not a particle. Initially, or in 10th standard, we were taking it as a particle, right?
Yeah.
So let's see what is the difference. Okay, what is the result that we
Okay.
get? So
Okay.
first of all, let's draw a perpendicular line, a normal to the surface. So we know this is our angle I, incident angle. So since
Yeah.
air is passing from rarer to denser medium, the ray will not follow its original path, but it will bend towards the normal, right?
Yeah.
Yes or no?
Yes.
So this is the thing. Okay. Now, as you can see, let's call this point P. So here, this ray incidents first, then comes this ray, right? Because it is lagging some distance. This is the path difference, right?
Yeah.
Okay. So let's call this point Q. Okay. So eventually, it will reach this point. Yes or no?
Yes.
Okay. So let's draw a perpendicular line. Let's draw a line that connects these two rays. Okay.
Oh,
Let's call this point B. This point is R. This is our refracted angle. Okay.
okay.
So as you know that this angle is I, that means this is also angle I, right?
Yeah.
And if this angle is R, that means this angle is also R. Yes or no? From the geometry.
Yeah.
This is our
Yes.
refracted wavefront. Okay.
Okay.
And this is 90-degree angle. This is also a 90-degree angle. Now let's say this part of a plane wave was having a velocity v1. That means here this distance would be v1 into t, because as to reach from this point q to b, it will gonna take some time, right? So we have taken
Yeah.
it as a t, and as you know that velocity is distance by t, so x is vt. So that way we have written that this distance is v1 into t. All right.
Yeah.
Okay. So similarly, here in this second medium, the velocity or speed of the plane wave or a light changes, right? Because here the medium is different. Whenever a light ray or any ray enters into another medium, its velocity changes. Okay. So let's say it is
Okay.
here in this medium, it is traveling with velocity v2. That means this distance would be v2t, right? Alright? So this is our
Yeah.
diagram. Now let's proceed further.
Okay.
So let's write some things that this QB is V1T, this is our first point, and this PR is V2T. This is equation number 2. Now from triangle PQB, where is triangle PQB? This is our triangle, right? PQB. This is our right angle triangle, yes or no?
Okay. Yeah. Yeah.
So in this triangle, we can write sine I is equal to what? This is a acute angle, that means this is opposite side, right? So it would be
Yeah.
V1T divided by hypotenuse, yes or no? And this PB is
Yes.
our hypotenuse, right?
Yeah.
So V1T over PB. That means
Okay.
PB is basically V1T divided by sine I. This is equation number 3. Alright. Now from triangle PRB, where is triangle PRB? This is our triangle PRB. We can again write sine R, right?
Yeah.
And sine R would be, this is perpendicular side, so that means this is hypotenuse again. So it would be V2T divided by P, or you can say PB is equal to V2T divided by sine. This is equation number 4. So we are having two values of PB. So we can equate these values, right?
Yeah.
So V1T divided by sine I is equal to V2T divided by sine. You can cancel out these t's and will end up with V1 by V2 is equal to sin I divided by sin I. Yes or no?
Yeah.
So this is our famous Snell's law. Yes or no?
Yeah. Yeah.
So we derived this relation. So this is the relation between two speeds, right?
Yes.
So this prediction is opposite to the prediction as per the Newton's corpuscular theory. So if mu1 be the refractive index of light in medium 1, we know that the relation between refractive index and speed is c by v, right? So mu1 we can write it as c by v1 and mu2 as c by v2, right? So you can
Yeah.
substitute this value. We'll end up with sin I divided by sin r is equal to v1 by v2 is equal to mu2 by mu, right?
Yeah.
And also we can write this QB, which was V1T, as n into lambda 1, and PR, which was V2T, as n into lambda 2. Okay, let's call this equation number 5. You can substitute this value here, and the final result would be sin I divided by sin R is equal to V1 by V2 is equal to lambda 1 by lambda. Okay,
Yeah.
this is our final result. This is the relationship between speed, wavelength, and the angle. So we derived this relation using wave theory. The frequency of the wave does not change. One thing you must remember, that when a ray or a wave front passes through one medium to another, frequency remains constant. Okay,
Okay.
it does not change at all. So this was the theory.
Yes.